Hello everyone, welcome to Digital Communication Tutorials. In this video, I am going to take up the third numerical on Schmidt Orthogonalisation. Let me read out the question first. Check whether the given signals phi1 of t and phi2 of t are orthogonal, and the signals are shown in the figures here below. Part B of the question says, obtain the corresponding orthonormal functions. And lastly, part C of the question says, express the given signals S1 of t, S2 of t and S3 of t which are given below in terms of phi1 of t and phi2 of t. This is actually a numerical based on Schmidt orthogonalization. However, here we are not supposed to create any basis functions because the question itself has given the basis functions which are phi1 of t and phi2 of t. So, all we are supposed to do here is to verify whether the given signals are orthogonal, and if they are orthogonal, check if they are orthonormal. If they are not orthonormal, make them an orthonormal set, and then finally represent the given signals S1, S2 and S3 in terms of the orthonormal functions. So, let us start with the solution part. I am going to start with part 1 of the question here, that is to verify if the given signals phi1 of t and phi2 of t are orthogonal. We know that any two signals phi I of t and phi j of t are orthogonal if the condition integral 0 to capital T phi I of t into phi j of t dt equals to 0. I will write down that condition here. Let us call it as equation 1. Now, for our given signals, let us apply this equation and try to verify whether this results in a 0. If you look at phi2 of t, it is defined with two different amplitude levels from the values 0 to 1 and 1 to 2. Therefore, now I will split this by taking the interval limits as 0 to 1 phi1 of t into phi2 of t dt plus integral 1 to 2 into phi1 of t into phi2 of t dt. Let us try to find what this results in. Integral 0 to 1, phi1 of t value between the interval 0 to 1 is 1, phi2 of t is also equal to 1. So, it is 1 multiplied by 1 dt plus integral 1 to 2, coming back to phi1 of t. Phi1 of t between the interval 1 and 2 is 1, whereas phi2 of t is minus 1. So, this will be 1 multiplied by minus 1 dt. Therefore, this results in 1 plus minus 1 equals to 0. Thus, we can now conclude that the given signals phi1 of t and phi2 of t are orthogonal. That is about the part A of the question. Let us now move on to find part B answer. The part B of the question says, obtain a corresponding orthonormal function. But please note, we did not check whether the signals are orthonormal or not. How to find whether a given signal set is orthonormal? It is quite simple. If the energy of the orthogonal signals is equal to 1, then such a set of signals are called orthonormal signal set. So, all we are supposed to now do is to find whether phi1 of t and phi2 of t have energy equals to 1. If it is 1, then they are already orthonormal. If they are not 1, then we go on for part B by finding new orthonormal functions. So, let us now try to find the energy of signal 1. So, I will call it as E phi 1 and is given by integral 0 to t phi 1 square of t dt. We know that the signal phi 1 of t is defined over the interval 0 to 2 and the value of that signal over that interval is 1. So, it will be 1 square dt. So, this will result in 2. Similarly, let me move on for finding the energy of the signal phi 2. This is equals to integral 0 to capital T phi 2 square of t dt. I'll split the integral limits from 0 to 1 and 1 to 2. So, phi 2 square of t dt plus integral 1 to 2 phi 2 square of t dt. Between 0 to 1, the value of phi 2 of t is 1. So, it is 1 square dt plus between 1 to 2, the value of phi 2 of t is minus 1. So, it will be minus 1 whole square dt. So, this is equal to 2. Right. So, now you can see that the given signals phi 1 of t and phi 2 of t have non-unit energy. Therefore, as previously already shown, they are orthogonal but not orthonormal. Let us now write that down here. Right. So, how to find an orthonormal set when you already have an orthogonal set? The answer for that is quite easy. All you need to do when you already have an orthogonal set is to simply divide the orthogonal set by the value of the corresponding signal energy, and when you do that, that corresponding signal set will convert itself into an orthonormal function. Let me just write down that point here. Therefore, for the given signal set phi 1 of t and phi 2 of t, the orthonormal functions are first one is phi 1 of t divided by square root of E1, and second one is phi 2 of t divided by square root of E2. Therefore, the orthonormal functions are phi 1 of t divided by root 2 and phi 2 of t divided by root 2. These are the orthonormal functions. Lastly, we move on to the part 3 of the question, where we are asked to express the given signals S1 of t, S2 of t and S3 of t in terms of phi 1 of t and phi 2 of t. To be very honest, we do not have to really compute any coefficients to do the same, because by graphical analysis it is possible to express either S1, S2 or S3 in terms of phi 1 and phi 2. How is that? Let us come and look into S1. Look at S1, it is defined over the interval 0 to 1 and it has an amplitude of 2. So, if I take phi 1, which is defined over 0 to 2 and has an amplitude of 1, add it with phi 2, which has an amplitude of 1 between 0 to 1 and minus 1 between 0 to 2, then the resulting signal will have an amplitude of 2 between 0 to 1 and 0 between 1 to 2, which in fact is our S1 of t. So, we can now therefore write S1 of t is simply phi 1 of t plus phi 2 of t. In a very similar fashion, I can extend the theory for S2 of t. S2 of t equals minus of phi 1 of t plus phi 2 of t. Please note, minus of phi 1 of t means the value of phi 1 of t over the interval 0 to 2 is minus 1. So, minus 1 plus 1 cancels out. So, there is nothing between 0 to 1 in terms of S2 of t here, and after that between 1 to 2 it is minus 1 plus minus 1, therefore, it is minus 2. So, it properly adds out. Lastly, we have S3 of t, which is simply phi 1 of t minus of phi 2 of t. I will leave the analysis to you. Coming to the last part, now let us express the signals in terms of phi 1 and phi 2. As I already have said, S1 of t is equal to phi 1 of t plus phi 2 of t. S2 of t is equal to minus of phi 1 of t plus phi 2 of t. Lastly, S3 of t is equal to phi 1 of t minus of phi 2 of t. That is about the answer for the part 3 of the question as well. Right. So, in this numerical, we have found whether the given basis functions are orthogonal, Then we checked whether they are orthonormal, and since they were not, we converted the orthogonal given signal set into an orthonormal signal set. That is done by dividing the orthogonal signal set by their energy. And lastly, we have expressed the given signal set in terms of the given orthogonal basis functions. Well, that is the end of this numerical. If you like this video, kindly like and share this video and subscribe to my channel for more information on digital communication. Thank you for watching. Have a good day.